So today we're going to be continuing in section 7.6 talking about the natural logarithm. Again, the same essential understanding as last time. When the base of an exponential equation is the number e, we're going to use a natural log. Okay, so some prior knowledge, e is approximately 2.718, and the log base e of x can be rewritten as just ln of x, the natural log of x. We need to remember the relationship between exponential form and logarithmic form, and then always those properties of logarithms. So our first example today would be to solve the natural logarithmic equation ln of x is equal to 2. So with the prior knowledge that we have, knowing that the base of this logarithm is e, we can rewrite this as e to the second power is equal to the part x. Well, that's easy enough to evaluate. X is already by itself, so again, just second and then the natural log button brings up the e command. Mine already raises it up to an exponent, so you just type in squared. And again, round these to 3 decimal places, so 7.389. Okay. When we have to use those properties of logarithms, we just have to remember which one is which. If you are adding two logarithms together with the same base, and these are both natural logarithms, so they have the same base, you do what to their parts? Well, you multiply them. So you have the natural log of 2x times 3, which is 6x, is equal to 2. So then the next step, the natural log is all by itself. Its base is e, so we can go ahead and rewrite this as e to the second power is equal to the part which was 6x. And again, from the last problem, e squared is 7.389 is equal to 6x. So all we would need to do here is divide both sides by 6 to figure out what x is equal to. And again, round to 3 decimal places. So 1.232 in this example. All right. On your own, get the natural logarithm by itself first, and then evaluate it. So pause the video, go ahead and do that right now. And hopefully you end up with that. Now with this, these are the two answers you end up with, plus or minus 33.115. You are allowed to have both the positive and negative answer here because the part of the logarithm is squared. If you put in the negative 33.115, you would still square it first, so then you would be okay. Because you remember, you cannot take the log of a negative number. Okay, that's no solution. Same with 0. That's no solution. It doesn't; those don't exist in the domain of a logarithmic function. Okay, going the other way, if we have an exponential equation with a base of e and we wanted to solve it, we're going to use a natural logarithm. So again, get your base by itself. Now the base is just e here, so don't forget about that 4 to get rid of that as well. First thing we're going to do, subtract this 2 over. So we're left with 4e to the 2x power is equal to 14. Okay, we have to divide by this 4 before we convert it to logarithmic form. So 14 divided by 4, we're going to have 3.5 there. So we have e to the 2x power is equal to 3.5. Now that we have the base by itself, we can convert it into logarithmic form. So if I have the natural log, because log base e, of 3.5 is equal to 2x. All right, well, the natural log of 3.5, you can actually just type that into your calculator. Okay, there's a natural log button. So you just hit the natural log of 3.5, hit enter, again, round to 3 decimal places. So you have 1.253 is equal to 2x. So we divide by 2, So x is going to equal 0.626. Last problem that I want to show you is this one right here. If we have multiple parts in our exponent, it's not going to change the process at all. The process stays the same. Okay, we still need to get rid of the 5 first by subtracting 5 over. So you have 2e to the x minus 2 power is equal to 8. You go ahead and divide by 2. So e to the x minus 2 power is equal to 4. Now that we have the base of the exponent by itself, you can go ahead and convert it into natural logarithmic form because it's the base of e. So ln of 4 is equal to x minus 2. Now don't just add the 2 over and say it's the natural log of 6. That would be wrong. So you have to take the natural log of 4 first. Natural log of 4, which is 1.386, is equal to x minus 2. Now add your 2 over. So x is equal to 3.386.